All right, we've been working with law sines and cosines the last couple of days. I had a couple worksheets dealing with law sines and cosines. Is there any questions, and also areas of triangles? Is there any questions you have in regards to law sines and cosines? Once again, hopefully you have some familiarity to law sines and cosines from what we've done in previous classes. Hopefully it's not going to be sitting there going, man, I don't quite know what I'm doing here. The ones that make you work a little bit is the ones where you're trying to solve for the angle. Whenever you're trying to solve for an angle, I always like to use law of cosines, but you can use law of sines to be able to solve for an angle, and we'll talk about something today with respect to law of sines that you have to watch out for. But questions you have on anything law of sines and cosines? Yeah.
Question number 4.
Question number 4. Measure of angle Y. We have triangle A. We have H is 5. We have Y is 8. And we have the measure of angle A is 79 degrees. So once again, get your picture down. Anatomically, it does not have to be correct. Just get yourself a picture down so you have a visualization. Label your triangle. You can label as whatever you want. I go from upper right to lower top and then left to right. Sides opposite, once again, are lowercase. So we have little h is 5, little y is 8. A, and then the measure of angle A is 79 degrees. And what I ask you in that problem is, what is the measure of angle Y? But I ask you to find angle, or I ask you to find little a first. Little a, you can use your law of cosines to be able to find little a. So we have a squared is equal to 5 squared plus 8 squared. Minus 2, 5, 8. Cosine is 79 degrees. And once again, we're just using law of sines and law of cosines here. I had the presumption that we were pretty much done, but I see a lot of heads down. So, solve for little a. Mind you, as you go through these problems, it's somewhat easier if you use letters first as you go through them. Once again, law of cosines, we have Pythagorean idea to begin with. A squared is equal to h squared plus y squared. That is a Pythagorean idea. Or if you have a y squared plus h squared, it does not matter. But it starts out Pythagorean. But then you have sort of a correction because it is not a right triangle. And remember, the angle at the beginning or angle at the end has to be opposite to the side that you're solving for. So you should have bookends with respect to the same letters there. If you have big A at the end, you should have little a at the beginning. If you have the big Y at the end, you should have little y at the beginning. Mind you, as you click this through the calculator, this will give you a squared. So you have to take the square root of your answer. So you have second square root, second answer. Corbin, what did he come up with for little a? 8.59. So we have 8.59 there. The second part of this question, I asked you to find angle y. angle y. Once again, I tend to, you can use law of sines and law of cosines. You have to watch out for law of sines. We'll talk about that today. So I always go back to law of cosines. You don't have to worry about making a decision. If you keep law of cosines, keep it as a law of cosines, you can write yourself a law of cosines equation. So if I have the cosine of angle y at the end, write yourself a law of cosines equation with a cosine of angle y at the end. Use only your letters in there, that's fine. And then substitute your numbers in. Using A's, H's, and Y's. Micah, if you start out with, or if you have cosine of angle y at the end, how do we start out with over here? And then finish your equation. And once again, if you have a squared plus h squared and then ah here, it does not matter. You can have it either way. Substitute all your values in. And we need to solve for cosine of angle y. So, as we talked about this before, take your take your 5 squared and 8.5 or 8.59 squared, take it to the other side by subtracting. And then also create a coefficient of your negative 2 times 5 times 8.59. Don't lose track of your negative sign here. You have a negative 10 here, so just going to move your decimal point over one place. But don't lose your negative sign. Get an 8 squared minus 5 squared minus 8.59 squared on the left-hand side. Also, if we have 8 squared minus 5 squared minus 8.59 squared, what do we get with? I can't hear you.
Oh, negative 34.79.
Negative 34 point what?
79.
79?
Yes.
Good with that. Okay, then we could eliminate our division, multiplication by division. Once again, don't feel that you have to create a decimal here, because once we do this, these go bye-bye. To solve for angle y, we have the cosine of angle y. What do we have to do to both sides to get rid of the cosine, Noah?
You have to do inverse cosine.
Inverse cosine. So we have inverse cosine here. And inverse cosine over here. So you can just take the inverse cosine of your fraction. You don't have to create a decimal out of that and then recopy the decimal. Keep it simple for yourself. Once again, there's something you have to watch out for. If you use law of sines, it's doable, but there's something you have to watch out for with the law of sines. Law of cosines will get a correct answer every time, because it'll give you one solution. Courtney, what do you come up with? 66 point. Good with that? Like I said, if you use law of sines, and some of you may have done that, which is fine. Sine of angle y over 8 is equal to sine of 79 over the 8.59 that you found there. But you have to be careful when dealing with the law of sines and trying to find the measure of an angle. You could get a little bit of a hiccup when doing that. And we'll go through that today. Of the ambiguous case, not as fun for me as the trapezoid. The trapezoids are my favorite figures. I just like the zoids. You throw the Z in there. I feel like there should be an action movie or an action thriller, The Return of the Zoids. And you have these people that are coming in that all have trapezoid heads or something like that, and it's The Return of the Zoids. Bless you. Bless you. See, wouldn't that be fun, The Return of the Zoids?
Yeah.
Sometimes I get you, sometimes I don't. All right. We have triangle ABC here. We have little c is 8. We have little b is 7. We don't know little a. We want to solve for little a. We know the measure of angle b is 50. And we want to solve for little a. Well, the problem we run into is in this form, we have a tough time. We don't have enough information right here to be able to solve for little a. Oh, we could, but it's really, really involved. So we have to do a preliminary step to be able to find little a. And that preliminary step is to find angle a. Now, we've went through the law of sines, we've went through the law of cosines, and the easiest one to work with is the law of sines. Okay, it's just, you don't have to worry about square terms in there, and it's just a little bit easier to work with. So if we look at our 3 law of sines ratios, that must be in proportion for any triangle. The sine of an angle to the length of the side opposite will be in proportion. So if we first write out our 3 law of sines just using letters, hey, Ms. Sweeney, what do you have? Okay, sine of the angle A over little a equals sine of angle B over little b equals sine of angle C over little c. Well, what we know here is we know B, we know C, and we know angle B. So we know 3 values of a proportion, which if we know 3 values of the proportion, we should be able to solve for the 4th value of the proportion. So if we substitute in here, We have sine of 50 over 7 is equal to sine of angle C over the value of 8. We can cross multiply and divide and solve for the sine of angle C, not angle C, but the sine of angle C, which hopefully we have the sine of angle C equal to some value. We can solve for that value of angle C then. Go ahead, check your answer with somebody around you. And solving for angle C, taking the inverse sine of both sides, we have 8 times the sine of 50 divided by 7. And taking the inverse sine of both sides, what do we get for the measure of angle C here? Anna, what do you get?
61.1.
61.1 degrees. So we get angle C to be 61.1 degrees, which now if we use our properties of triangles, we can add all of our angles together to get 180 degrees. If I have 50 degrees for angle B, 61.1 degrees for angle C, what does that leave for angle A? Sophia, what do you get for angle A? 68 point what? 36 degrees. And if you go 68.4, that is fine. Which now, I know 3 angles, I know sides here, I now know what angle A is. I can now solve using these 2 ratios and that proportion. I can solve for little a. Go ahead and substitute in for angle A, angle B, little b, solve for little a. And once again, check your answer with somebody around you. Alex, what do you get for
8.5.
8.53? Yes, no, maybe so? With that? All right, which we solved for little a. But now, and if I look at this triangle, anatomically, it sort of looks correct to my numbers. Okay, it's not exact, but anatomically, I got 3 angles that are roughly around 50 to 65, 70 range. Okay, so I got acute angles there that are sort of big. Okay, if I check my properties, my smallest angle is across my shortest side. My biggest angle is across from my biggest side. So all my properties that I have of triangles match up. But if we take a look at this triangle once again, here's the exact same triangle ABC. If I take the exact same conditions, which was little b is equal to 7, c is equal to 8, measure of angle B is equal to 50 degrees. The exact same conditions. What I'm going to propose to you is if I would put a hinge up there at A and swing side B over to here, which was 7 here, can still be 7 over here. We created what type of triangle here? Type of triangle. Two sides congruent? Isosceles. We created an isosceles triangle here. We just put side B on a hinge and we swung it to the other side here. So we can have the exact same length as we have here, but now it's over here. It's just hinged over to the other side. If we look at this, it is a second possibility of this triangle. The question is, we use the law of sines up here, and we used them correctly. Everything we did up here was correct. And we came down to a triangle that looks like what it should look like. And my calculator, because my calculator always tells me the correct answer, gave me those values. Why? Because it was the calculator. The question is, how do we get a possible second triangle out of this? Well, we did everything correctly up here. We had the sine of 50 over 7 is equal to sine of angle C over 8. We did that correctly. We multiplied both sides by 8, so we have 8 sine of 50 divided by 7 is equal to sine of angle C. We did that correctly. We took the inverse sine of both sides. We did that correctly, and we got the measure of angle C is equal to that 61.1 degrees. Everything we did there was correct. But now we have to think back to what we have dealt with in trig, and when we were solving equations in trigonometry with trigonometry functions, we were solving the equations there. When we took the inverse sine to solve a problem, we got our calculator value, which we call what value? You remember? Calculator value? Principal value. But we also have to worry about is what? Supplement. So we have our principal value here, but we also have to worry about the supplement. So if I take a look at 61.1 degrees, what would be the supplement to 61.1 degrees? 118.9 degrees. Taking 180 minus 61.1, I get my 118.9. So the measure of angle C down here, measure of angle C down here, we can also say is 118.9. So if I have 50 here, 118.9, how much does that leave for angle A? Tristan, how much does it leave for angle A?
11.1.
11.1. Which, once again, anatomically, that looks correct. We now have an obtuse angle down there. Okay? We now have an obtuse angle. So we can now, once again, use our law of sines to solve for little a. Go ahead and use your law of sines to solve for little a again. But now use my different angles. I always go back to the given. I know for sure 50 and 7, those were given to me. So I always go back to them because if I boofed up this one right here, everything else going to get boofed up. So I go back to I know what is true here, 7 and 50. So now what do we get for little a? Colin, what do we get for little a? Didn't do it.
Still working.
It's still working on it. It looked like you were relaxing.
No, I was just thinking about what I was doing.
Chris, what do you get for little a? 1.76, which anatomically, once again, biggest angle, biggest side. Smallest angle, smallest side. Anatomically, I'm correct. I've fulfilled all my properties of triangles. So we get two solutions there. The problem you run into with law of sines is when you're trying to find an angle with law of sines, you have that possibility of getting two solutions. And you have to make sure that you have the correct one of those two solutions. The trickier ones is when you use your law of sines and you get like 85 degrees and 95 degrees. Okay, those are really, really tricky. Make your check with respect to the sides, opposite angles. Now, what this now goes back to, and we talked about this trig a little bit, is when you were in geometry and you were trying to prove triangles congruent in geometry. You went through 4 postulates of proving triangles congruent. You had the side. That said if 3 angles or 3 sides of one triangle are congruent to 3 sides of a second triangle, then the 2 triangles were congruent by the side postulate. Then you have the side postulate. If 2 sides and the included angle of one triangle are congruent to 2 sides and the included angle of the second triangle, then the 2 triangles were congruent by the side postulate. Then you had the angle postulate. If it says 2 angles on one side of one triangle are congruent to 2 angles on one side of the second triangle, then the 2 triangles were congruent. Then you had the angle side postulate that said 2 angles of one triangle and the non-included side of one triangle congruent to 2 angles non-included side of a second triangle, then the 2 triangles were congruent. And you went through those scenarios up there, and then of course you sat there and snickered a little bit, and you said, well, you have all these possibilities. Where's the angle side postulate at? Where's the angle side? If I have 2 sides and the not included angle of one triangle are congruent to 2 sides and not included angle of second triangle, why aren't those congruent? By the angle side postulate. Come on, Miss Fennel. Come on, Dr. Clark. You guys still have Clark back there? That's all Fennel. Why does that not work? Well, right here is the reason why. Because we have 2 sides and a non-included angle of one triangle. Congruent to 2 sides and a non-included angle of the second triangle. When you say 2 triangles are congruent, you should be able to put one right on top of the other, and it should look like one. If I put this triangle on top of this triangle, it's not going to look the same. Now, you can probably run a corollary. I call this a Gregor corollary, which is an offshoot of the postulates. Called the Gregory. It will work when the angle is obtuse. It will work. when that angle is obtuse. Maybe there was something there. Maybe Euclid threw it out there somewhere and I never read it. Okay, I don't know. But if this angle is obtuse, then it would work. But if the angle is not obtuse, it may work and it may not work. Okay, so you have to watch yourself by using your law of sines to be able to find the measures of angles, because it could possibly come down to two angles like we did here. And anatomically and property-wise, the triangle works. Once again, it's the one thing you have to watch out for with using law of sines to find the measures of angles. If you use law of cosines, it's cut and dry. Okay, you're going to get one answer only, because when you do the inverse cosine, remember back to what we did with solving trig equations, inverse cosine, we had the calculator value or principal value, and it's what? Opposite. Well, we're not going to put a negative 50-degree angle within the triangle here, so we don't have to worry about that. But when you deal with sine, inverse sine, principal value, and supplement. Questions? All right, we have more law of cosines and sines and triangle problems to do. Everything is at your disposal now. Everything is at your disposal with respect to solving the triangles. And if the instructions are say solve the triangle, okay, that just means find all the values that are there. I missed somebody? There we go. I had two left. I only need one left. All right, you got about 5 minutes here. Should be able to get a lot of it done here.